Hello and welcome to I Know Dino. Keep up with the latest dinosaur discoveries and science with us. I'm Garrett.
And I'm Sabrina.
And today in our 509th episode, we've got a bunch of news.
Oh yes, so much about sauropods, including a new rebbachisaurid and more sauropod individuals found in multiple formations that show just how diverse they were. Plus there's some lumping of sauropods.
That is a lot of sauropod action.
Mm-hmm. We also have an interview with Susan Butz, where we talk about the newly renovated Yale Peabody Museum, and that, of course, includes their updated brontosaurus.
Oh, way to tie it together.
Mm-hmm. And dinosaur of the day, Ruyangosaurus, which is a Titanosauriform sauropod that was very large.
That is a sauropod-tastic episode.
Yeah, it's going to be great.
Plus, we've got a Dino-all challenge, the last puzzle that we're going to do for the entire contest. It may or may not be about a sauropod. You'll have to listen to see.
And we have our fun fact, which is definitely about sauropods. It's that giant sauropods lived a lot longer than we thought.
Oh, really?
Mm-hmm.
Yeah, it's been hard to know because they don't always have lags, so you can't count them as easily as some other dinosaurs.
Yes, and in this case, they couldn't do that either.
Oh, well, I'll be interested to hear how you know that they're old. So before we get into all of that, we want to thank some of our patrons. And this week we have 10 patrons to thank. They are Cassidy, James Pasco, Sam, Mrs. H, Adam, Ayrton and Everett, Dom Likes Dinos, Thomasaurus, Kate, and Stevoceratops. It's been a couple of weeks since we gave a new shout out, but if you'd like to help us create the show and get a shout out, please consider joining our community at patreon.com/iknowdino. One of the things you'll get, in addition to ad-free episodes and I Know Paleo and other perks, is access to our fantastic Discord server. I have to give Dilophosaurus credit for a really solid joke on Discord. He said, if a mosasaur were to suddenly turn up at their house, it would be a very Dino-all challenge. 2 dinosaur podcasters are at home in California when they hear a loud sound outside. A large marine reptile has suddenly appeared in their front yard. Their I Know Paleo research tells them it's a mosasaur. It seems very unhappy about being on land. But what body of water should they release it into? An ocean, a river, a paddling pool, or a puddle? And as I was reading this, in my head, I was doing the same sort of intonation as if I was
the way you read it.
Yeah. And then they gave the Patreon question of, the mosasaur seems to be hungry, so they decide to pacify it with food. But what would it most like to eat? A goat, a shark, Garrett, or Sabrina?
Oh, I hope it's not 2 of those.
For the record, I'd put it in a river delta so it could choose to swim more to fresh or salt water, because I feel like we wouldn't know for sure. I think one time we mentioned maybe some of them were fresh water. And I would feed it a goat, but only because I wouldn't know where to get a shark, and I don't want to feed one of us to it.
But I think a shark might be the right answer there.
The shark is probably the right answer, but I don't have a shark, so I give it a goat.
Mm.
And lamniform sharks weren't really all that common. So
if Rexy can eat goats, this mosasaur can eat goats.
Exactly. That's what I'm thinking. So thanks for the laugh, Dilophosaurus. Both Sabrina and I really enjoyed that, and we're laughing as we read it. So.
Oh, yes, definitely. And thank you, everyone, for being part of our Dino-all community. Like, this example from the Discord server is just emblematic of how amazing the community is.
One of many great messages that we've read over the last few days.
Yes.
And weeks.
Years. All right. Before I get to the news, I just want to do a quick correction. Thank you to our patron, Marcus, speaking of our Dino-all community, who pointed out a mistake in last week's Dinosaur of the Day. The dino of the day was Cayentevenador, but Dilophosaurus did come up a lot. And when talking about Dilophosaurus, I mistakenly referred to it as a coelophysoid, but it's no longer considered to be a coelophysoid. There's been a few studies on this, starting with one in 2015. Christoph Hendricks, Scott Hartman, and Octavio Matias wrote an overview of theropods and their classification, and Dilophosaurus was considered to be a coelophysoid for many years. That's where my mistake came in because the papers I was reading was pre-2015.
Yeah, that's always the thing when you're going back to old papers. You have to know which parts of it need to be updated.
Mm-hmm. But more recent and larger scale analysis found that Dilophosaurus was more derived than coelophysoids. And even though where exactly Dilophosaurids are classified as unresolved, they were in a different group from coelophysoids. So according to their paper in 2015, it's in Dilophosauridae, which is a poorly supported clade, but it contains dinosaurs such as Dilophosaurus and Dracovenator. But then the plot thickens. A study in 2019 by Marianne Zahner and Wynen Brinkman found Dilophosauridae to be a valid clade and also include Cryolophosaurus. So sure, that seems to answer the question, except a year later, in 2020, there was a redescription of Dilophosaurus that did not find Dilophosauridae to be valid. And they found, for example, Cryolophosaurus was a basal neotheropod, and that the features that Cryolophosaurus and Dilophosaurus had in common, like their crests, were just an ancestral trait for ceratosaurs and tetanurans.
Yeah, we see crests show up all over the fossil record, so it wouldn't be surprising if different unrelated dinosaurs had that feature.
Yes. So for now, we'll just stick to calling Dilophosaurus a neotheropod. And that's a very broad group because it includes most theropods.
But not coelophysoids.
Yes.
Yeah, I should have remembered this because when I did that overview of theropods the other day as a listener question, I totally avoided Dilophosaurus because
too confusing.
I think I might have even mentioned, like, I'm not going to talk about Dilophosaurus. It's too weird.
And I stepped in it.
Yeah.
All right, but enough about theropods because this is our sauropod episode.
Mm-hmm.
So there's a new rebbachisaurid, Campananeyen fragilissimus.
Maybe fragilissimus, depending on where you put the emphasis.
For some reason, I'm having trouble with that species name. I did like the title of this paper. It was published in Historical Biology by Lucas Lerzo and others. And the beginning of the title is They All Floated in the Cretaceous.
They all floated? Is this like a bloat and float situation?
No, it has to do with the lightness of its bones.
Oh, okay. So maybe it would have literally floated while it was alive?
I don't know about that, but it was light. It was a highly pneumatized skeleton, lots of air sacs going on. So rebbachisaurids were basal diplodocoid sauropods. They appeared in the early Cretaceous. They lived until the early late Cretaceous.
So like 50, 60 million years?
Something like that. And they're known for those highly pneumatized skeletons that are just full of air sacs and very light, which would be really helpful when you're as big as a sauropod.
Yeah.
And rebbachisaurids have been found in South America, Africa, North America, Europe, and possibly Asia. Rebbachisaurids are also known for their teeth, and some of them even had tooth batteries. Now, this rebbachisaurid, Campananeyen, was basal and was closely related to Cytosaura. Both of them lived in the late Cretaceous in the Cordilleras Formation in what's now Argentina. Cytosaura is one of the largest known rebbachisaurids. It's estimated to be about 15 tons and 18 to 20 meters or 59 to 65 feet long. And it was named earlier this year, if it sounds familiar. We talked about it in episode 479, so not too long ago. Campananeyen had unique features in its hip bones. That's why it's getting a new name. And its hip bones had air sacs and was really thin and fragile.
Weird. You would think hip bones on such a large, heavy animal would need to be super robust and not thin.
Yeah, it had this just extreme pneumaticity in its skeleton. So in the hips, the air sacs invade and provide resistance to support the forces of the muscles. And hips are really important for muscle attachments. So since it's so thin, it may have needed some structure to help it so the muscle forces didn't collapse the bone structure of the hips, or else the hips or the ilium would be too weak. The genus name Campananeyen refers to the Las Campanas area where the fossils were found and combines it with Nayen, which means air in Mapudungun, and refers to the great pneumaticity of the dinosaur. And the species name, fragilissimus, means most fragile in Latin and refers to that thin ilium or hip bone.
Ah, like fortissimo when you're playing music means very loud.
Oh, yes. So the holotype of this dinosaur includes the brain case and part of the skull, part of the hips, a tail, vertebra or bone, and toe bones. Parts of the skull were described back in 2016, but the dinosaur wasn't named until now. The fossils were found near a small unnamed rebbachisaurid, as well as a small abellisaurid, a turtle, and a lizard-like animal.
A turtle.
I knew you were going to say something.
Of all those, that's what I focus on.
Yeah. We don't know what happened there. It was just there.
We just know it was dead next to a sauropod.
You know what? They've all been dead a while.
True.
So the brain case of Campananeyen has unique features. It's got two halves of the brain case, and it has a shallow depression on one of the skull bones, known as the quadrate, which is larger than other rebbachisaurids. Its toe bones are also unusual, and they kind of end in teardrop shapes, and one has 3 little bulges, so it could be a pathology, but unfortunately those bones are just too poorly preserved to know for sure. But Campananeyen helps show that rebbachisaurids originated in South America and then early on diversified to Africa and Europe. In the early Cretaceous, South America and Africa were close, and Africa and Europe were also close, so that can mean that rebbachisaurids went from South America to Africa to Europe. Some other animals that lived around the same time and place as Campananeyen include another rebbachisaurid, abelisaurids, turtles, snakes, crocodiliforms, and mammals. In addition to that unnamed rebbachisaurid, there's also Lemmisaurus, Napshospondylus, and Ruyangosaurus. There's also titanosaurs like Ondosaurus, theropods like Giganotosaurus, and the Thyreophorm Yakapil.
That's a cool one, Yakapil.
Mm-hmm.
I'm a fan.
I know you are. Funny how you pick out all these other animals when I'm talking about the sauropod.
The Thyreophorm and the turtle.
Yeah.
That's a really interesting dinosaur.
Mm-hmm. Thin hips.
Yeah, or air.
Well, air-filled hips.
As the Mapudungun translates it to. It's a good name.
Mm-hmm.
It's a little bit hard to say, Campananeyen, but I like the meaning.
I do too.
Maybe they could have done something slightly different with the Nayen part, made it a little cooler, but...
Oh, I think it's cool. For whatever reason, I have trouble saying the species name more.
Fragilissimus.
Yeah. So moving on to the other sauropod news. There are some new Titanosauriform sauropods that have been found in the Portezuelo Formation of Patagonia. This was published by Kevin Gomez and others in BMC Ecology and Evolution. Unfortunately, well, maybe not too unfortunately, they didn't name any of the new sauropods because they're being very cautious.
Okay.
And that's because it's mostly tail bones, caudal vertebrae.
Sometimes sauropods get named based on vertebrae.
Sometimes.
But maybe the tail vertebrae aren't as good because you don't get as much pneumatization and some of the other stuff.
Part of the problem is you can't compare with other already named dinosaurs because they're not overlapping.
Gotcha.
So these fossils were found in February of 2023. They found 2 individuals. In one individual, there's 5 non-articulated tail bones, all very damaged. And then in another individual, there's 3 isolated tail vertebrae, part of an arm bone, the ulna, and a hand bone. And these individuals were found almost 1,000 feet or about 300 meters apart. So that's why they're considered to be 2 different individuals.
That makes sense. I mean, I guess you could have bones that spread out 1,000 feet during the
fossilization process?
Yeah, or even before, just getting scattered by either weather or other animals or what have you. But that's pretty far.
Mm-hmm.
It's definitely too far to assume that they're from the same individual just because they happen to be similar sized animal.
Yeah. And a lot of fossils have been found from this formation too, but only 2 species have been formally described from there. Malarguesaurus and Photolongosaurus. And both of those are sauropods. Malarguesaurus was a large titanosauriform. We know it from tail bones, ribs, and parts of the arm and leg.
Tail bones.
That's true. And they found differences between these new fossil finds and Malarguesaurus in the neural spine of the tail bones, but that could just be due to individual variation.
Okay, so there was a little bit of difference.
Yeah, but maybe not enough.
Mm-hmm.
They also found in one of the new individuals, when they compared it to Malarguesaurus, there was a different combination of features, so it could mean they are separate species. But again, these authors said that they're being cautious. Photolongosaurus was a large sauropod, and we found a complete neck, backbones, ribs, and 1 tailbone. So it's a little hard to compare well because there's just no good overlapping of elements. So again, they said, well, these bones, they're just too incomplete to name. But it does help us learn more about sauropods from this area of Patagonia and show more diversity, so future fossil finds will help even more. Another case of hashtag need more fossils.
Yeah. Yeah, you did say with the tailbones, most, if not all, are very damaged. So,
And I don't think it's the same tailbones that corresponds to the one tailbone of Photolongosaurus.
yeah. But even if they were, right, if they're super damaged, it can be hard to see the details that make Photolongosaurus unique. And so you might not even be able to tell if the other one had those features.
It was damaged in one individual, but I don't think it was damaged in the other.
The one that has just the one tail vertebra?
No, 3. So Photolongosaurus only has one tailbone, but one of those new individuals has 3 isolated ones.
Oh, and those aren't so damaged. Gotcha. Need more fossils. Need better fossils, maybe.
All the fossils. Well, that brings me to my last news item about sauropods. There's some lumping happening here. So Australotitan, also known as Cooper, which we've talked about Cooper a lot on this show, and we got to see Cooper
Yeah.
in Australia.
I usually say Australotitan, like Australia, Australotitan.
Good point. Australotitan. But we might not need to say it anymore because it could be a junior synonym of the sauropod Diamantinasaurus.
Oh, weird. I feel like Diamantinasaurus is so much smaller.
Yes. So this was published in Peer J by Samantha Beeston and others, and they looked through hundreds of bones from the Winton Formation in Queensland, Australia. These bones are from about 98 to 95 million years ago. And that area at the time that the sauropods lived was covered in rivers, swamps, forest pools, coastal estuaries where tides meet streams.
So much more wet than the outback we know today.
Oh, yes. It's kind of perfect because you want conditions to be dry to find the fossils.
That's true. And it helps if there's some water to fossilize things.
And sauropod fossils have been known in Australia for over 100 years, but many of them are incomplete. However, over the last 15 years, there's been a lot of new discoveries and descriptions. So this team, they 3D scanned over 500 fossils, and then they compared them all to look for new features. They ended up describing 12 new sauropod specimens. They described a lot of specimens that hadn't been described before but are in museum collections. 2 of them were Diamantinasaurus, 2 were Savanosaurus, 3 were Wintonotitan. The other 5 were too incomplete to know. And then they also reevaluated 4 species of sauropod from the Winton Formation. And they found that the description of some of these new remains that they described, or these new descriptions from the formation, showed that some specimens had unique features of more than one species. So they did a whole reassessment of the sauropods. And they said that Australotitan cooperensis, Cooper, was probably the same, meaning a junior synonym, as Diamantinosaurus. And like you were saying, that would make Diamantinosaurus much bigger because Cooper's the largest dinosaur found in Australia so far.
Yeah.
That would mean that Diamantinosaurus could get up to 100 metric tons or 110 tons and be up to 25 to 30 meters long or 82 to over 98 feet long.
I feel like those weight estimates are a little bit on the high side, but yes.
Could be.
It was huge.
Now, even though they did say Australotitan,
I feel like Australotitan is better, actually. This is why I shouldn't worry about pronunciation.
Well, even though they said it was probably a junior synonym to Diamantinosaurus, because there's a lot of similarities between the two, they also said they didn't find any unique features of Australotitan that differentiated it from Diamantinosaurus, but they found that they only share one unique feature of Diamantinosaurus, and then there's 3 shared traits for the clade Diamantinasauria. So they said that Australotitan was an indeterminate member of Diamantinasauria, and that clade includes Diamantinosaurus, Savanosaurus, Wintonotitan, and Sarmientosaurus. It's a little up in the air right now, but it sounds like Cooper is not its own dinosaur. That's the main takeaway.
So part of the time they say that it's a junior synonym of Diamantinosaurus. So then it would be literally Diamantinosaurus. But then they also say maybe it's not actually Diamantinosaurus, but just a really close relative of Diamantinosaurus.
So they're thinking, yeah, it's probably a junior synonym, but to be on the safe side, it's Diamantinasauria undetermined, inserte sedis.
Oh, okay. Somewhere in that group. But if it is just another species or, even genus within Diamantinasauria, it could still be Australotitan. And then it would just be in a different part of the family tree than we thought before.
Well, I need some more research or more fossils.
One might say.
Give us those fossils.
Mm-hmm. And in just a moment, we'll get on to our interview with Susan Butz from the Yale Peabody Museum. But first, we're going to pause for a quick sponsor break. And now we're going to get into our interview with Susan Butz. But first, I just want to mention we're talking all about the Yale Peabody Museum, since that's where she works. But you may remember we have talked to somebody from the Yale Peabody Museum before. And previously, it was Mariana Di Giacomo. That was in episode 338.
Back in 2021, so a lot has changed at the Peabody since then.
Yes, but we talked about the renovation was already going on with the Yale Peabody Museum, and it was sort of what's the state of the restoration like? And I think they were still even moving things around. They had just set up some protection for the big Zallinger mural and everything.
Mm-hmm.
So if you want to get sort of an earlier point in time, you could listen to that interview.
Yeah, you can kind of hear how it progressed.
Yeah, and there's an extended version of that interview for our patrons. And as well, there's an extended version of this interview with Susan. And if you'd like to check that out, patreon.com/iknowdino. But without further ado, on to our interview. This week, we're joined by Susan Butz, the Director of Collections and Research at the Yale Peabody Museum, with a background as an invertebrate paleontologist. Thank you so much for joining us.
Thanks, Garrett and Sabrina. I'm excited to be here and talk about the Peabody Museum and our dinosaurs.
Yeah, and I think after over 500 episodes, you might be the first invertebrate paleontologist we've had on our show.
Maybe.
Well, I'm happy to do so.
Got to represent most of the animals on Earth.
Yep.
I just want to say first, congrats on the reopening of the Yale Peabody Museum.
Thank you. It's so exciting. We've got so many people coming through the door. You just walk through and it's just busy, busy, busy. Kids everywhere. And so cool to see after 4 years of being closed.
Yeah, that is a long time. It must be strange where it seems like everybody's back in your space again after all those years.
It really is. We slowly saw it progress from, be completely deconstructed and then built back up with all of our exhibits going in. As you can imagine, we had all these dinosaur mounts out in the past. Those had to be disassembled, brought to Canada to Research Casting International. A lot of work was done on them there, and all the new mounts were made. And then they had to be brought back and assembled piece by piece in the Peabody Museum, along with all of the other specimens we've added to the galleries on 3 floors of museum.
That's so cool.
So, as Director of Collections and Research, what was your role like the last 4 years while all the renovations were undergoing?
So I was involved first as the collection manager for invertebrate paleo, and then as the Director of Collections and Research in helping to coordinate the exhibits on the first floor. Our entire first floor are the paleo exhibits, and it's basically a walk through time. So we're starting at about 580 million years ago, looking at Ediacaran fossils, and you walk all the way through time until you're at modern humans and sort of how we're changing the environment today. And through that walk through time, we sort of take the approach that we're looking at 2 things. Life affects the environment, and the environment affects life, and also extinctions change everything. So as you walk through the galleries we have on the first floor, you sort of get that theme throughout. And so we have our Ancient Oceans Hall, Life Among Dinosaurs, which is the Mesozoic Dinosaur Hall, World of Change, which looks at mammals in the Cenozoic, and then our final hall on the paleo floor is the Human Footprint, and that looks at what happens once humans enter the scene.
A lot of things.
Which is also very different. Yeah.
Yeah. Mm-hmm. Yeah. So I was working with curators, working with all the other content experts like postdocs and graduate students, pulling together information and content, working with exhibits on how you construct a good theme, and then working to translate the work of curators along with, there's lots of people working on this, not just curators and me and exhibits, lots and lots of people, making it into something that's really approachable to lots of people, accommodates different levels of interest and different levels of time and devotion to walking through the galleries and sort of getting it into this great package that's ready for visitors.
Nice.
Yeah.
Did your museum also expand the gallery space at the same time?
We sure did. So we had our second floor. So we're 3 floors. The second floor was almost entirely devoted to administrative offices. Those have been completely removed and relocated to a brand new 4th floor, which is just administrative space. And then also there was a courtyard between this 3-building complex, which is the Geology Building and the Environmental Science Center and the Peabody Museum. And we built up this big courtyard, which has this really fantastic central gallery with living plants in it from the Botanical Garden at Yale Marsh Botanical Garden. And then also houses our vertebrate paleo collections and brings them all together in one new place. So they were formerly spread about these different buildings, and now they're all together, and they've got this state-of-the-art prep lab. It's just really fantastic for vertebrate paleontology and for all the visitors to vertebrate paleontology.
Yeah. And it's free admission to everyone now, right?
Yeah, free admission.
Oh, awesome.
It's fantastic.
So the Marsh Botanical Garden, this is the first I've heard of that. Is that named after O.C. Marsh?
It sure is, yeah. It's in his backyard.
Oh, really?
Yep. So the Marsh House is up the street from the Peabody Museum, and the Botanical Gardens are sort of his backyard, and there's greenhouses there.
Yeah.
Yeah. And the director is a curator at the Peabody also.
Oh, that makes sense. Yeah. The Peabody was Marsh's space.
Yeah.
Yeah.
Yeah, I know, because Peabody was his uncle, right? And then-
Exactly. Uncle Peabody coughed up the money for the original Peabody Museum. So
It was a good deal.
It was.
Yep. Uncle George.
One of the things I'm most excited to see when we do finally one day get to visit is the renovated or the updated Brontosaurus.
Yes.
Is it still labeled as Brontosaurus?
It is Brontosaurus.
Okay.
It actually is Brontosaurus.
Yeah. Well, I know there are some differing views.
Yep. It went back and forth. But this one that we have, this is Brontosaurus excelsius. It's the same Brontosaurus that was on display beforehand, before we closed. And it's the OG Brontosaurus. It's the one that was collected in 1879, named as a new species by Marsh in 1879.
As you do.
Yep, collected out in Wyoming at Como Bluff. It's probably like 150 million years old. But it looks a lot different than it did when it was on display before.
Right. I read you guys had a 1/12 scale model, and then you were able to kind of figure out what needed to be changed based on that. And there were a lot of changes.
There were a lot of changes. So the biggest one and the most noticeable one to people is that the tail's in the air.
Mm-hmm. And longer, right?
It's longer. Yeah, we have, I think we added 27 vertebrae.
Oh, jeez. That is a
so
lot.
It ends up being like 10 feet longer. And that's why when you walk in, you'll see the Brontosaurus is kind of diagonal in the room. You have to sort of fit it into the room diagonally. But yeah, so we've raised the tail. We've known forever that dinosaurs don't drag their tail behind them. And this one was mounted in the 20s.
Mm-hmm.
So it needed a little help. And you could tell that something was wrong with it because it had a little kink in its tail where they forced the tail down. And so there's a couple other new features. We actually put the ventral ribs on it.
Oh, nice.
So we knew from other specimens and from living vertebrate specimens that it did have these ventral ribs. So we added belly ribs to it. And I think we changed the pose a little bit. So, the tail is up in the air and it's doing this sort of sinuous whip.
Mm-hmm.
And also one thing that's super cool is as you walk from ancient oceans into the dinosaur hall, you get this very dramatic reveal. And the Brontosaurus very intentionally has a sort of bird-like cock to its head. That was inspired by the fact that birds are living dinosaurs and that we really wanted to get that out and make sure we had poses that represented, what would be a dinosaur, not like elephants with dinosaur bones.
Yeah, that's also really playful rather than it just being some monster.
Yeah.
Yeah, it's super fun. So we did have that scaled model, which we worked with RCI. So Jacques Gaudier the collection staff, the preparators in vertebrate paleontology. We had a postdoc named Advait Zucker who was super instrumental in helping us with these things. And so we sat down and we had like these summits looking at, tweaking the model, taking pictures of it from different angles. And then before that, even, we had so many Zoom meetings, because it was during COVID, so many Zoom meetings looking at YouTube videos and sort of capturing screenshots of things that we wanted to emulate in our mount, looking at publications, consulting with other experts, just to make sure every single bit is perfect.
Nice. Yeah, because it might be another 100 years until it gets adjusted again.
It's not easy to adjust.
I know the Stegosaurus also got a pretty hefty update.
Yeah, so Stegosaurus, it was on display previously also, and it has better proportions now. So the legs were a little out of proportion with its body and with its other legs. And so we revised the proportions of the legs. It also has fewer thagomizers.
Oh no, it's thagomizer shrunk.
Fewer spikes on it.
Well, it's got 4 now, which is what we usually see. Yeah.
Yep, and we had 8.
It was twice as good.
Yeah, twice as gnarly.
Twice as wrong. Maybe.
So that, and then also it has this neck armor now.
Oh, I love the neck armor.
Yeah, the neck armor is super cool.
It makes it look really cool. And the other thing that's great about the dinosaurs is that before they were sort of in this rink that you couldn't get close to them. And now the way that we've redone the exhibits is that you can get really close to the mounts. And for the Brontosaurus, you can walk under the head and you can walk under the tail. And it really gives you a much better sense than it did before of how big they are when you can stand right next to its leg and say, oh, wow. Imagine this thing with muscles and skin. That's scary.
Yeah.
Imagine it actually cocking its head at you.
Yeah, exactly.
That's very cool.
What about for the Age of Reptiles mural? Did you have to do much for that?
Well, the Age of Reptiles, it's 110 feet long, and it's actually built on the wall.
Yeah, it's like a fresco, right?
It's a fresco, yeah. It's a fresco secco, which is a dry fresco. And so we had to renovate this entire museum around a 110-foot, one-of-a-kind artwork that's super famous and basically made of rock and attached to the wall. And so it was very, very important. We had conservation staff and other museum staff that monitored it all the time. It actually had scaffolding built around it. And so in that enclosure, it had its own heating and air conditioning and controlled humidity. It had its own security, vibration monitors, seismic monitors, observation windows, like limited lighting. And you can imagine that happening at a time when there's jackhammers on the wall below it. So I don't recommend doing that if you can avoid it, but it looks gorgeous. It has been conserved, and there were some issues. It is built to the wall and it is made of minerals because it's plaster. So there are sometimes little deposits that form on it. Paint will flick a little, will peel up a little bit. And so we spent a lot of work getting it back in shape. And the unveiling, it was totally covered up. When we unveiled it, there was a bunch of people that got to stand on this observation balcony that we have now overlooking the dinosaur hall. And you just felt like crying. It was so beautiful to see it back and so vibrant. And the whole museum is so much more light filled than it was. We've opened up all the windows, and the Great Hall was, it was kind of 20s, kind of burlappy and dark. And now it's just gorgeous and light filled, and it just makes the mural shine even more.
That's so cool.
That is.
Yeah, we only recently learned that originally Zallinger got hired to just do a few paintings, and then he sort of talked his way into doing this massive mural.
Yeah, and this is a guy who just graduated from art school.
Yeah.
That's the
It's
cool thing
unbelievable.
about the Yale Peabody. Like, not only do you have these amazing displays and specimens in for research and everything, but like there's also this human history to it because, like we were saying, Marsh, that was like his spot, but then you've got like John Ostrom years later, and he
Yeah.
starts the whole dinosaur renaissance. You've got like just so many big names.
It really
Yeah.
is. I mean, it's a fantastic place to be and so much cool work going on now.
Yeah. So the third we've talked about, I think, the first two floors a little bit, but the third floor, is that open yet? I read maybe it
The,
didn't open right away.
the third floor is partially open, but still a little bit more to go. So the third floor has what we call the living lab, and the living lab has living frogs, fish, butterflies, really cool objects that visitors can touch. So they can handle, it's all real fossils and real minerals and real crabs. And we've put it out in a way that visitors can handle it. And, they're obviously not museum specimens that we wouldn't be happy losing, but it's okay if you break one by accident.
Mhm.
We're okay with that. We want people to be able to handle specimens and feel them in the same way that scientists do. Also, we have our dioramas, which were always there beforehand. They've been around for a long time, but we did have them conserved, especially the artwork on the back walls, which needed a little bit of help, and then the taxidermy in those.
Mhm.
And we also have Dynamic Nature, which is our biological gallery, and the mineral halls. And the mineral halls are mind blowing, basically. I'm a
Cool.
geologist, so I'm kind of biased, but they're
Yeah.
absolutely like fantastic, spectacular, jaw-dropping, beautiful display. It's sort of dark, and the fossils are really well lit, and they just glow, and it's fantastic.
Is there some of that radioactive stuff that you can highlight
I don't
or
think they have the guy. I haven't seen that yet, but that doesn't mean it's not coming. There's also
Yeah.
a big section on gems,
Hmm.
which
Mhm.
is phenomenal, and a gallery called Hall of the Pacific, which is Pacific artifacts and items. So we will see those opening pretty soon.
Nice.
That's great.
It's always fun to go in and see all the different types of rock. It's also interesting because you notice the different chemicals and you'll see like all the different versions of quartz. It's like these are all
Yeah,
the same chemicals, but they all look so
I know.
different.
I mean, I'm biased there too, but quartz is awesome.
Yeah,
Yeah.
Silica is awesome.
it is.
It sounds like Yale Peabody has been doing a lot of digitizing lately too.
Yeah, so 14 million specimens. We do what we can, and we've been getting these big digitization grants to digitize specific parts of our collections, especially in order to prepare that material for a research question that people want to ask. So, one that was a recent project between invertebrate paleo and vertebrate paleo was digitizing the Western Interior Seaway material.
Oh, cool.
Yeah, both divisions have a lot of material. It's fantastic. It's well preserved. It's well documented in terms of the locality information. And so we were part of a multi-museum grant to digitize Western Interior Seaway fossils at all of our museums and put them into a site. We use iDig Bio and iDig Paleo so that you can search all the museums at once
Mhm.
and do things with the Western Interior Seaway that people couldn't do before, like look at ecology, look at how ranges change with sea level change and climate change, how you can use that information to help predict how ranges of animals now might change in light of climate change. Just a lot of really cool questions you can answer with digitization. And we really have tried to push the boundaries of how you digitize at the Peabody Museum. So making sure we're doing things like rapid data capture, these sort of tools that facilitate high throughput digitization. So getting a lot done, because with 14 million specimens, it could go on for the rest of our
Yeah.
lives if we don't come up with clever ways to digitize.
So what is are the main tools like structured light or photogrammetry, or is it all the above, depends on the fossils?
I mean, we're mostly using imaging, but they just like images and then image stacking.
Mm-hmm.
So taking multiple images at different focal planes and then stacking them together to make really nice images. But we experiment a lot with taking a picture of an entire drawer and then capturing the individual specimens in that drawer electronically. And then you can do things like AI interpretation and OCR of cursive and things like that. And then another thing we're working on is in our informatics, we have a person, Nelson Rios, who's working on something called lightning bug with other colleagues. And that is looking at pinned insects. And so an insect is pinned, and the pin goes through the body of the insect, but it has 1 to 30 little teeny tags attached to it with its cursive letter. And so he's working on these special cameras, these special systems that sort of digitize from lots of angles and then can put the little tags back together so that you can read them, even though you viewed them from all different sides and you can't really see them if you just take a picture. So just really fun and creative ways to digitize.
Nice.
Yeah. Can you tell us about like any of the research that's currently going on at the museum? Is there anything you're allowed to talk about?
Let's see. So one of the things that just came out fairly recently is some work on Deinonychus.
Oh,
Ooh.
nice.
Yeah. So Deinonychus, Deinonychus from Jurassic Park is Velociraptor. Michael Crichton based Velociraptor on Deinonychus because obviously Velociraptor's a little too wimpy
A little small.
to fight humans.
I don't know if I've heard the word wimpy before, but I get where you're going
isn't
for.
The best term.
It is in the context of attacking a bunch of larger animals.
Yeah, I mean compared to Deinonychus.
Yeah.
Right. And it was described by John Ostrom, and it was one of the things that really made people start to really believe that birds are living dinosaurs. And so one study that was recently done by Armida Manafzada and Anjem Bullar at Yale and Stephen Gatesy was that they figured out new ways to explore biomechanics in fossils. So they have a study that first did x-rays of birds walking, and then it took out those bones and it sort of looked at how the bones move and fit together, and then came up with sort of a score for how that works. And then they used scanned bones of Deinonychus from the collections, and they could actually figure out how it walked and how it could use this terrible claw.
Mm-hmm.
So it has this second big claw. It's the terrible clawed lizard.
Yes.
And so that is named after this second toe that it has, that's really big sickle-shaped claw. And so they use that to model how it would walk and how it would kick and pin animals using that claw. And because it just came out, it's made our Deinonychus fossil that's on display already outdated.
Oh, no.
But that's awesome. Like that's like what we live for at the Peabody is, that's science, right?
Is it doing like a midair kick or something?
No, so it just needs a little toe tweaking.
Oh, okay.
So that's something
that
could be updated.
Yeah. And so those people, and then also lots of people in the Gautier and Buller labs, postdocs and graduate students, help do these fantastic animations we have in the halls. So under the mural, we have this evolution of locomotion exhibit, and it explores the evolution of locomotion in 3 different parts. The first one is the movement from water onto land, then being able to breathe while running, and then flight. So what we tried to do is tell these stories and look at how bones that we have in the collection have clues that support how these evolutionary features or these evolutionary changes have allowed new types of behavior to happen. So things like walking on land, a lot of the tools that are used in walking on land actually evolved underwater. And so we look at things like these features and help people to understand fossils the way that scientists do. So we're not going to say, look at the occipital condyle and blah, blah, blah. And we don't want to display stuff like that. But we say, look at this little thing. This little thing tells us that this animal could lift its head down, and we think it did that to catch prey. And that's something that you'd need if you're moving onto land and you can't just swim into your prey.
Oh, cool.
Yeah, so along with those 3 sort of segments, we have these big touch kiosks. And they have these fantastic animations on them where sometimes the animals have bones and sometimes they don't have bones. And we point out those certain features. And so this group of scientists was really important in making sure that this was super scientifically accurate and up to date and informing things like how a Deinonychus walks. So when we have a Deinonychus walking, it's like how a Deinonychus walks. It's not just some little cartoon that somebody made. It is scientifically informed.
Nice. I love when you are looking at a cladogram or like a tree of life and you have the little points that are really important, it often seems like the defining feature is so trivial at first. Like I think of with birds, it's like this moon-shaped wrist bone. It's like, really? That's the this little wrist bone, that's the key thing? Or like you were talking about the angle of the head, the ability to angle a head down. It doesn't seem like when you see this big animal with sharp teeth, you focus on like the jaw musculature and the size of the head and all that. And it's like, well, that was sort of later.
Yep. Yeah. And so like when we do the exhibits, we talk about the semilunate carpal, right? Which is a little half moon-shaped bone. But we try and, the kiosks helps with this, but we also try and give sort of visual imagery that helps you understand what we're talking about. So in talking about the movement, we say, imagine someone playing the cymbals, right? That is the movement that we're talking about, and how a movement like that can eventually lead to flight.
Yeah.
So we try and the labels are actually written at an 8th grade level. And that's not because we just want 8th graders to enjoy themselves. It's because when you visit the museum, there's a lot going on. There's a lot of people. You might be dragging around kids or being dragged around by kids. And we want to make our text accessible to lots of people. And so we've also done this style of writing where there's a title and then there's a big idea. And then there's more information. So if you want to just see the title and get a sense of what's in the case, you can. The big idea will give you about 1 sentence of what's in the case, or you can read on if you want to. But it's pretty punchy. It's pretty fun text, and it's very relatable.
Cool. Yeah, that's hard to do.
Yes.
Yeah. Yep. And it's hard. It's super hard to write text short.
Yes.
Like how do you explain really complex paleontological and evolutionary concepts in 40 words without using a lot of lingo?
Yeah, and without oversimplifying it, because you want to be correct without being...
Yeah.
But still want to keep everyone's attention.
Yeah, and teach them something new, not just tell them something really obvious where it's like, oh, of course, yeah, I already knew that.
Yeah. And tell a story across a whole floor.
Yeah.
Yes.
Right? Like bringing it back to these key concepts.
So how close to like the deadline of the opening were these things being finished up, and was it like down to the wire, or were you pretty ready to go in advance?
It depends. We're still working on a couple things. So things like the big dinosaurs were really kept on track. That was sent out to RCI. And there was like strong timelines. But the main thing that happens is not that like people got off schedule or anything. It's that, we changed specimens out. So we might have gone through and prepared this really fantastic object and then decided we just couldn't get the text to work with it. And so now we have this really fantastically prepared object that isn't on display, but something cool has gone in its place still. So we had that. And then there's some things like installing a touch specimen. And we have these great touch specimens that, they're generally cast from real objects. And they're in this sort of bronze effect. But down to the wire, screwing one in and it cracks.
Oh.
So is there a backup? Or something's really fragile and we have a hard time putting it in. I think the things that were very last minute were the text labels and like the little numbers that you put next to the fossil. And it's good because those were changing with the text at the last minute. So, but we got it all open on time. So
Nice.
pretty excited. Yeah.
It's like squeezing in the table of contents at the last minute as like the
Yeah,
book
exactly.
is changing around.
Is there anything we haven't asked you about that you want to highlight?
I guess some of the new things that I'd like to talk about a little are the Connecticut fossils. So we have a fantastic display of Connecticut fossils, and Connecticut's sort of known for footprints.
Mhm.
But we do have one dinosaur that was discovered in Connecticut that's on display that's really nice looking. And we have a lot of dinosaur footprints, and including one big slab that has dinosaur footprints and raindrop impressions in it.
Oh, cool.
Yeah, so you can see these little pock marks all over the slab. So you know that dinosaur was running through wet mud at the same time it was raining, which just seems like the most implausible snapshot that could ever be preserved.
I was just trying to think, like, how does something, because I always imagine things getting filled in by like water, like driving some sort of sediment on top of it. And like, how does it do that without disturbing a raindrop impression?
Yeah, they must have just been just dry enough that whatever, when the next floodplain deposit came in, it filled it in without disturbing it.
That's amazing.
It is.
One other thing that's really cool is our Western Interior Seaway.
Mm-hmm.
So we have a really cool exhibit that's sort of ecologically themed. You can see all the different levels of animals within the ocean. We have a Zoophanctinus.
Yeah. Does it have another fish inside it?
Not this one, but we do have a gar eating another fish.
Okay, good.
And probably its last meal. But the Zoophanctinus, it used to be like way up high on this wall in the Great Hall. And then we brought it down so that it's eye level now. And it just has a piece of glass in it. So you can get right up close and see the teeth, which are scary.
Mm-hmm.
Yeah.
No joke, scary. And then we also have our famous Archelon hanging in the central gallery.
What's Archelon again? Oh, that's a big turtle, right?
Yeah, the big turtle. Yep. So it was on display also, but it was sort of propped on its side, like on its tail against the wall behind glass. And now it is soaring over the central gallery. And we do know that Archelon has evidence of prey damage because its rear flipper is bit off.
Oh.
And there's signs of regrowth.
Oh, man.
Oh.
So at some point in its life, it lost a flipper. And so we thought, well, that's a pretty good learning opportunity. We hung a Tylosaur behind it. So it's being chased by a mosasaur with its mouth open. It's all glass in that room in the central gallery. So that is just really dramatic. And it's a place that has big comfy chairs, and you can just go hang out in there and give your kids a snack. And it's just a really cool effect.
That is cool.
That is.
Yeah.
Cool. Well, where's the best place for our listeners if they wanted to find out more about you or your work, or of course the museum? Where can they go online?
Yeah, so you can find out more about the Peabody Museum at peabody.yale.edu. And that's where you get all the information about what to do when you're visiting. And so right now we do have time tickets, but there are lots and lots of walk-up tickets. Like, I don't think anyone's been turned away. So don't be intimidated by the fact that you can book tickets. We are open every day except Monday. And also, like, the best part about this major renovation is now it is completely free. So you can just come as many times as you want. You can come twice a day if you want. It's free. We will be changing exhibits a lot. So we have these really versatile systems. So as there are new discoveries, we can just really easily put them out and put out new fresh labels and get to see all the cool stuff we're working on at the Peabody Museum.
Awesome.
That's great.
Yeah, I love those. I've seen, I think the first time I saw it was at the Royal Tyrrell. They had like a fossils in focus, and they were swapping out different displays.
Cool.
And maybe I remember that one because it was dinosaurs. I'm sure I've seen it elsewhere. But
Yeah.
Well, thank you so much for taking the time to chat with us today.
Yeah, thank you.
Yes, that was super fun. Great to hang out with you guys.
Yeah.
Thank you so much, Susan, for chatting with us. It was so great to hear about all the cool new stuff going on at the Peabody. I can't wait till we get to visit it ourselves.
Mm-hmm.
And we'll be back with our dinosaur of the day in just a moment. But first, a quick break for our sponsors. And now onto our dinosaur of the day, Ruyangosaurus, which was a request from Paleo Mike 716 via our Patreon and Discord. So thank you. It was a Titanosauriform sauropod that lived in the early Cretaceous in what is now Henan, China, found in the Haoling Formation. It was a very large sauropod, so it had a long neck, a long tail, and walked on all fours. Of course, it had the small head, like sauropods did.
Yep.
And it probably had a wide body. It was estimated by Gregory Paul to be about 98 feet or 30 meters long and weigh 55 tons, over 50 metric tons. So that's on the big side for a sauropod.
Mm-hmm.
There was another estimate that it was 115 feet long or 35 meters long based on its femur or thigh bone. And then it kind of got pared down a little bit. There was a 2020 estimate that it was over 81 feet or almost 25 meters long and weighed 37.5 tons or 34 metric tons.
So you've got 100 feet plus or minus about 20 feet and...
Very heavy.
Yeah, very heavy, somewhere in the 30 to 50 ton range.
Yeah. There's one paper from 2017 that showed skeletal and life restorations of Ruyangosaurus with some hypothesized osteoderms, some spikes that are on the end of the back and beginning of the tail. And that's where I got the idea that it also looks like a very wide dinosaur. That'd be so cool if there were spikes there, but I don't think we actually know. That wasn't found. The type species is Ruyangosaurus giganteus. It was described in 2009 by Jun Chang Lu and others. The genus name means Ruyang County lizard. It refers to Ruyang County of Henan province. And the species name, giganteus, means large in Greek and refers to it being a, quote, huge sauropod dinosaur.
That's what they actually said, a huge sauropod dinosaur.
Yes.
That's funny.
According to the paper that named it, they said, quote, the new sauropod obviously represents a new and gigantic dinosaur and represents the largest dinosaur found from Asia so far.
It's kind of nice to see something written in a little more common English.
Yeah. I like that it's obviously represents.
Mm-hmm.
So it's one of the largest dinosaurs of the Eastern Hemisphere. The holotype includes a couple of vertebrae, a couple of ribs, part of the right thigh bone, and a complete right lower leg bone, the tibia.
Okay, I'm getting a feeling for why there's so much variability in the length estimates
Mm-hmm.
when we're basically talking about ribs and limb bones.
Right. You need the neck and tail to help fill it out.
Yeah. Oh, you did say a couple vertebrae, but it's hard to put those together into a full length when you only have a few of them.
You just need all the bones all the time. More fossils all the time. There are 2 skeletons known, so you put it together. We've got neck bones. So there's some neck bones, back bones, part of the hips, tail bones, ribs, a complete right humerus or arm bone, a complete right femur or thigh bone, and a complete right tibia, lower leg bone.
Okay.
There's another large sauropod, Huanghotitan, that was found nearby, but its back vertebrae look different. With Ruyangosaurus, its back vertebrae is just much larger. So it's more robust than Huanghotitan. It's also hard to compare the two because different bones have been found of each. So you can't really compare apples to apples. But the centrum of the back vertebra, the middle part, is much larger on Ruyangosaurus. So that would mean that Ruyangosaurus was larger. Ruyangosaurus had a long, slender femur and a short, robust tibia. And it has similarities to Argentinosaurus, based on the width of the back vertebrae. That's also another very large sauropod.
I think calling it a slender femur is pretty funny. I'm sure it's just proportionally compared to some other sauropods, but like any animal that weighs over 30 tons isn't going to have that slender of a femur.
It's just compared to the tibia.
Yeah, okay.
So that robust tibia was 50 inches or 127 centimeters long, which is pretty big. It had some differences to Argentinosaurus, though, like in the neural spines and details in the arches, so that's one of the reasons we know it's not the same as Argentinosaurus. It also helps that it was found so far away.
On the opposite side of the earth.
Yeah.
I mean, some animals do get all over the earth, but yeah, not all the time.
So Ruyangosaurus helps show that there was more diversity in sauropods in the early Cretaceous in what is now Asia, and possibly that time period was key for the evolution and diversity of large Titanosauriforms. Pretty cool. And some other dinosaurs that lived around the same time and place include the sauropods Xianshensaurus, Huanghotitan, and Yunmenglong. as well as the ankylosaur Ruyangosaurus and the oviraptorid Ruyangia, as well as ornithomimids, iguanodonts, and carcharodontosaurs. Now, at the time that Ruyangosaurus lived, global temperatures were generally warm, and there were probably seasons, which might have helped angiosperms spread out, and that might have helped Titanosauriforms.
Yeah, there's always that question of what did the evolution of flowering plants have to do with dinosaurs? Did they help each other? Did one of them eat the other one a lot? Meaning, did dinosaurs eat a lot of angiosperms? I don't think people think angiosperms ate dinosaurs.
Not as far as we know.
Yeah. And now we're getting into our Dino-all challenge, the very last Dino-all challenge
That went fast.
of the contest. It did. But first, we need to review who won the last challenge. And if you remember, it was a dinosaur in a grocery store in the produce section, wolfing down all sorts of produce. And
Especially apples.
it liked the apples, yeah. I think you came up with that detail. But the question was, which dinosaur is it? And the answer was Nothronychus. The key detail there was we described its big, giant sloth-like claws that it was using like pitchforks. That was the only dinosaur that had big claws on it. I thought about throwing Therizinosaurus in it and making it real tricky to tell the difference, but I decided that
It's too much.
Yeah, too much. And the fastest person to figure out that it was Nothronychus was Jurassic Pirate. Well done, Jurassic Pirate. I think they got it at only like 5 minutes after the episode came out, if I'm detecting correctly. So that's impressive.
That is.
And then for our Patreon scene, we had the dinosaur that was getting agitated, running around the produce section trying to find something. The store manager gives it a bucket of water. It doesn't really want the bucket of water, but it's looking for something in the bucket of water. And the question is, what should they give it? And I gave some really random options of milk, blankets, chapstick, and gravel. And most people got this one. The answer was gravel.
Nice.
Of course, the reason a dinosaur might want gravel is if it needs gastroliths to help digest its food. So that's what I was going for there. It's like, oh, it's eating all this food. Maybe it needs some gastroliths, or it thinks it needs some gastroliths to go into its gizzard and help smash up food just like chickens and other birds do today. And so gravel is the only thing. There isn't really any reason a dinosaur would need chapstick or milk because, of course, they're not mammals, so they don't do anything with milk.
And there's debate about their lips.
Yeah. Blankets, maybe it would enjoy a blanket, but...
Well, who doesn't like a good snuggle under a blanket?
Yeah, it probably wouldn't be looking for a blanket in the bottom of a thing of water. So figured maybe gravel could be deduced. And the fastest patron to figure out that it was looking for gravel, potentially, was Pav. So well done.
Yay, good job, everyone. We will announce the person who gets the Dynamite prize package soon.
Yes.
Well, first we'll have, our last challenge and give everyone a chance to respond, and then we'll do it.
Getting a little ahead of ourselves here.
Yes. But as a quick reminder of what is in that prize package, there's a large Spinosaurus tooth, courtesy of Mini Museum, a real Eocene fossilized leaf, courtesy of Ancient Odysseys, a signed Why Dinosaurs poster, courtesy of Why Dinosaurs, Captive's color change slime eggs, courtesy of Toy Monster, a Dino-all Parasaurolophus patch, and an I Know Dino sticker. Pretty sweet.
Yeah, a lot of ways to win. And again, you get one entry for every answer you get correct, both in the Google Forms answers and on Patreon. So now, for this week's challenge, we're in Choteau, Montana. A family has been walking in a park for a while and is ready for a break. They spot a park bench and eagerly approach it to take a seat. As they get close, they hear a rumble under the bench and stop suddenly. Looking down, they're startled to spot a wild animal. At first, they think it's a loose dog, given the snout full of teeth and the long tail, but they quickly realize it's not a dog at all. It has feathers instead of fur and yellow, eagle-like eyes, which are staring back at them. It moves its neck in quick twists to make eye contact with each member of the family. It's quite small, not much bigger than a cat. It could be a baby or a chick or whatever you call this species when it's young. After a minute or two examining the humans, the dinosaur lays its head down on the ground. Maybe it's tired or hot. That could be why it sought shelter under the bench. The mom decides to try and give it some water. She cuts the top off a disposable water bottle to fashion a makeshift water bowl and slowly approaches the animal. The dinosaur lets out a hiss and she jumps, dropping the bowl and spilling half the water. Fortunately, the bowl lands upright, so it wasn't a complete loss. She backs up slowly to rejoin her family. The dinosaur cautiously creeps out from under the bench to examine what was dropped. As it emerges, the family gets a better look at the dinosaur. It is very bird-like with a narrow snout. It has a long, very stiff tail that goes from side to side as it moves. It seems to have long legs, which makes its crouching walk look a little bit awkward. Now that it's out in the open, it doesn't look too menacing. Including its long tail, it's less than 3 feet long. It looks into the water bowl and immediately loses interest. Then, in an instant, it rises up on its legs and springs into the air. For a moment, it almost seems to float weightlessly. For the first time, the family sees the large sickle claws on each of its feet. The dinosaur lands with both of its feet close together and stabs its claws into the dirt. Then it bends down and swallows a lizard whole from under its foot. It returns to its place under the bench, facing out and staring at the family. So the question is, what dinosaur is it? I'm just thinking of Dilophosaur Rob, the joke version. Is it a Daspletosaurus, Oviraptor, Orodromaeus, or Bambiraptor? And for our patron scene, the family had enough of the park and went to get some ice cream. They head to the old trail museum in town. After finishing their ice cream, they head into the museum to check out the dinosaur displays. Then they hear a whimpering-like sound, a baby dinosaur, small but with a bulky body and long tail. It's trying to cuddle up with the largest dinosaur replica inside. When it gets no response, it seems distressed. It looks like this baby needs to be reunited with its mother. They make a call and get redirected to the Fish and Wildlife hotline. They figure out it's probably a Maiasaura. There was a report of a Maiasaura in the wild earlier, but where was it? The options are Uncompahgre National Forest in Colorado, Two Medicine Lake at Glacier National Park in Montana, the Denver Zoo in Colorado, or a garage in Casper, Wyoming. So we talked about Maiasaura in a previous episode, so you have to figure out which location it was in.
Dig through those archives.
And it's a good reminder that you can answer any and all of these puzzles up until August 31st at 11:59 p.m. Pacific time. And to answer these questions, for the first question, it's bit.ly/dinochallenge508. And for the Patreon question, you can just get that link from the bottom of that form, or you can go to patreon.com/iknowdino.
And if you want to read all of the rules and restrictions for the Dino-all challenge, head over to bit.ly/dinochallenge24.
And at the top of that page, you'll also find a link to all of the different puzzles.
Yes. So good luck, everybody. I'm really excited to send out this prize package, and we had a lot of fun writing these challenges.
Mm-hmm.
And now for our fun fact, which is that giant sauropods lived a lot longer than we thought. This was published in the Journal of Anatomy by Carrie Woodruff, Brian Curtis, and John Foster, and they had a really fun punny title. It's Sizing Up, but SEIS, because the Seismosaurus is what they're talking about. Sizing Up the Super Morrison Formation Sauropods, because there's also a Supersaurus.
I see.
Or actually, it wasn't Seismosaurus, it's Supersaurus and Diplodocus, but anyway, good puns. So large sauropods, we know they're hard to bury and fossilize because they were just so enormous.
So you don't get full bodies.
Yes. And also, just because a sauropod or a dinosaur or any animal is large, it doesn't mean that it's fully mature. We see this with dinosaurs like Triceratops. For this paper, they studied Diplodocus hallorum and Supersaurus vivianae, both of which lived in the late Jurassic in the Morrison Formation, and they're both very large sauropods. They represent the verifiably largest, by body length, dinosaurs within the Morrison Formation. Because large could also mean weight, or there's a lot of ways to define large.
Yeah.
So they took samples of these dinosaurs' long bones and dorsal ribs, so limb bones, rib bones, and they looked at thin slices of them under a microscope, otherwise known as osteohistology. They found that both Diplodocus halorum and Supersaurus vivianae were skeletally mature when they died through the histology. Now, like you were saying earlier, Garrett, about the lags, usually we count lags with dinosaurs to get a rough estimate of the age of an individual. But in this case, you can't count the lags to know how old they are because there's just too much bone remodeling.
Yeah, so it sort of destroys the record if there was one.
Yeah. So they had to do something called retrocalculating. And retrocalculation involves measuring the smallest and largest space between those lags, which are kind of like tree rings, and marking off the distances between them, and then using the biggest spaces to calculate an estimate for the maximum age of the dinosaur. So it's not a perfect way to calculate, but it is something.
So they did have some lags to work with, just not as many as you would want.
Yes. And based on these retrocalculations, they found that Diplodocus halorum didn't live much longer after growing to adult size. At most, it's estimated to be about 60 years old, which is older than other dinosaurs that have been found. There's a 40-year-old Camarasaurus and a 50-year-old Carcharodontosaurid Meraxes.
Mm-hmm.
And this one's 60 years old at most. Now, even though sauropods grew fast at first, the large ones probably took decades to reach their full size. For example, Dippy took 24 to 34 years to reach 27 meters or over 88 feet long. That's Diplodocus carnegii. Diplodocus halorum took 60 years in this case to get to 33 meters long or over 108 feet.
Wow.
So that's the Diplodocus. The Supersaurus is a bit trickier. So they speculated that Supersaurus vivianae was 225 years old. But they said there's way too much bone remodeling, so they say approach this figure, quote, with extreme caution due to the limitations of the methodology. That's according to Brian Curtis's Fossil Crates. What we do know is that this Supersaurus lived a long time after reaching its adult size. We just don't know its exact age.
Yeah, 225 years seems
too long.
Very improbable.
It would be cool if that was true.
It would be. That would almost be approaching like those dragons and different legends that live for such extremely long periods of time and just keep growing larger and larger over time. It would be neat.
It would be.
But it's probably a lot younger.
Well, who knows by how much, though.
It would be surprising if it was over 100 years old. That's very rare in the animal kingdom.
That's true. If we're thinking, whoa, Diplodocus is 60 years old and that's so old, it seems like a huge jump from 60 to 225.
Yeah.
Well, that wraps up this episode of I Know Dino. Stay tuned. There is a new Abelisaur dinosaur to talk about. Plus, we'll announce the winner of the Dino-all challenge in our next episode. And again, for all the rules and restrictions, head over to bit.ly/dinochallenge24. Thanks again, and until next time.